I want to talk about the position update. Okay, the position update. And remember, we said that you know our final, or how we predict your future position, is equal to our initial plus the average delta t. Okay, so this is the average delta t. Okay, so in this case, we know that at a constant velocity, v average is equal to v final plus v initial divided by 2. Okay. All right. When the velocity is not constant, so when it's not constant, we know v average is defined to be the momentum final divided by the mass. Okay. So that being said, let's look at the problem and see if we could apply this knowledge here. So I have a problem here. It says 1,575 kilogram car is located at a position of 250 meters in the x direction, and it has a momentum of about 440,000 kilograms per meters per second. Okay, what is its location 14 seconds later? So the first thing I'm going to do is always start from my principle. So my momentum update formula says that R final is equal to R initial plus V average delta T. Okay, well, in this case, you got to assume that the momentum is not constant. That the velocity is not constant. Okay, because we have to use this this V average thing here, and there's no final and initial velocity in this problem. Okay, so we gotta assume that the velocity is non-constant. And so if I'm looking at this, I know my R initial, which happens to be here. Okay, I know my V average, well, we're gonna figure that out, and I know my delta T. Okay, so if I'm looking at this R final, now it becomes R initial, which is my initial position, 25000 meters, plus what's V average? It's a momentum final divided by the mass, and we know delta T to be 14 seconds. Okay, so if I'm looking at this, I know R final is 250 in the x direction meters, plus, well, what's my momentum? 440,000 divided by the mass, which is 1575 kilograms. And we know delta T to be 14 seconds. Okay, so if I'm squishing this down, this comes, our final now becomes 250 in the x direction. All right, plus, well, what's this huge number divided by 1,575? Well, if I look at my calculator, this becomes 44000. I'm going to divide that by 1575, and that becomes 27.900. Okay, because remember, I got to divide this as a vector, so I got to divide the 0 by this and the 0 in the z direction. Okay, times 14 seconds. Well, it's pretty evident to me that everything is actually going in the x direction itself. So I'm going to take 250 plus 27.9 times 14. Okay, and so my final position would be 640.600 meters. So this is how we update position. Okay, this is how we update position given a momentum and some sort of mass with initial position.